Okay, so this is take two because the first video decided not to save, so I'm going to do it again. Hopefully I can remember everything I told you guys. So a couple of housekeeping things. Again, I have not gotten addresses from Davin and Bailey, so if you want your test, you should email me your address. The second thing is if you will look in Blackboard, I've posted a week at a glance to kind of let you know what is going on with this week. We only have one quiz this week, and it's today, and I'm going to give it to you. It's not on MyMathLab, so I will give that to you. So also, as we do quizzes and tests and things on MyMathLab, please make sure that you're looking at due dates. Some of those due dates are going into the weekend because I want to make sure and give you guys 48 hours. So please make sure that you are looking at due dates. So, okay, so as we jump into chapter 14.3, it's talking about the Pythagorean theorem, the distance formula, and the equation of a circle. Now, in college algebra, you covered the distance formula and you covered the equation of a circle, or you should have. So I am not going to redo those. But we are going to cover the Pythagorean theorem, which you've already kind of looked at it when we did the trigonometry. So it should be a refresher. So you can kind of see the proof here and where it's coming from. You have two legs, and then you have what's called the hypotenuse. And the two legs, the square of the two legs, so the square of the first one plus the square of the second one is equal to the square of the hypotenuse. So a squared plus b squared is equal to c squared. C is your hypotenuse. It is always the side that is opposite your right angle. Your legs are always the line segments that come to create your right angle. So remember, right angles are 90 degrees. Your hypotenuse will always be your longest side. So if you're given three numbers and you're asked if it is a right triangle, then your longest number you can always assume should be your hypotenuse. Okay, just kind of a story for you here. It's kind of fun to read about the Pythagorean theorem. So the first thing we want to look at is determining if the following can be lengths of the sides of a right triangle. So again, if you have three lengths, you can put it into the Pythagorean theorem and know if it's a right triangle. So your largest one again should be your C. So you have a squared plus b squared is equal to c squared. And that should be equal. So if it is equal, then yes, you do have a right triangle. If it's not equal, then no. Okay, and you will use this on your quiz today. So the first two are yes. Remember, when you square a square root, the root goes away, so it's left with 13. Okay, and then the last one, 25 does not equal 49, so that means that 3, 4, and 7 are not sides of a right triangle. Okay, the next three are just given pictures, finding the values of your right triangle. So here I'm looking for the hypotenuse, so that should be my c squared right here. Remember, to get just c by itself, I want to take the square root of both sides. On the one on the left, that you're given the marking is 9, but you're also given that these two sides are congruent based on the two tick marks, and that means that this is an isosceles right triangle. So that means these sides are the same, and so they're both 9. So I can again find the hypotenuse. The one on the right, you're finding the leg, so it should be either your A or B, it does not matter, and then you should solve again for x. Okay, the word problem. A pole BD, 25 feet high, you can see it there in the center, is perpendicular to the ground. So remember, perpendicular, it comes down to a 90-degree angle. So two wires, so think about guide wires that come off electric poles or towers. So two wires, BC and BA, are 35 feet long and are attached to the top of the pole, and two stakes, A and C, on the ground. It should be A and C on the ground. If points A, D, and C are collinear, so that means they're on the same line, how far are the stakes A and C from each other? So D is right in the middle, smack dab in the middle, and we know that because they're both 35 feet from the top. So 28 feet high, so you know that your bases are going to be the same. So we're wanting to find A to C, but we can look at one triangle and we can find just a portion of that side. So you can use your 28 or your 35 and you can solve for the other leg. You get 21. But remember, 21 is just one piece of the bottom. It's not all the way across. But because they're the same, you can multiply it by 2, and so you get 48 feet across. Okay. The next one, find the height of the pyramid. So when we do surface area and volume, this is something that we will see. So to find your height, or sometimes we'll have to find the slant height, you want to take out a right triangle slice out of the pyramid. So I've kind of come down here and rewritten it for you. So you have your height. Your slant height of your pyramid is 620 feet, and that is going to be our hypotenuse of our triangle. And then our base, it's 771 feet across here. And so that means that just halfway across, this little line right here, is 771 divided by 2 feet. So you can find your height then based on the Pythagorean theorem. So our height is 485.58 feet. Okay, you can look at some homework. So today we do have a 2.6 quiz. It's not on my math lab. It's one that I'm going to attach, and if you will complete it and then take a picture and email me back, that would be great. So you're finding the side lengths using the distance formula. So let's refresh that just a little bit. So your distance formula is right here. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Remember, the little 1's and 2's right here are subscripts, and those are just denoting what point it is coming from. The x from point 2, the x from point 1, the y from point 2, the y from point 1. So what you're going to do is you're going to plot these 3 points, A, B, and C, and they're the vertices of your triangle, so you want to connect the dots. Create that triangle, and then you want to use the distance formula to find the lengths of your sides. So take the 2 points of each side, and so you'll do the distance formula 3 times. And you cannot assume that it's a right triangle, so you cannot find 2 and then use the Pythagorean theorem, because you can't assume it is. But then once you find all 3 sides, I want you to plug it into the Pythagorean theorem, and first of all, see if I have a right triangle. See if it's a true statement, okay? And then from there, based on your measurements of your sides, do you have a scalene triangle, an isosceles triangle, or an equilateral triangle? So remember, scalene, the sides are different, all different. Isosceles, you have two legs that are the same, and the equilateral, you have all sides are the same. So there should be 2 answers to this. It should either be isosceles, scalene, or equilateral, and then it should either be acute, right, obtuse. So and then just graph it and then show me work. So I should see 3 sets of the distance formula on your work, and I should also see you plugging it into the Pythagorean theorem. So that should be your work there. Again, look at the week at a glance. We're going to do 14.4 and 14.5 on Wednesday and Friday, and then that will lead us up to a quiz on Monday, and that will be over surface area and volume, and it will be on my math lab. So I know there's been some issues getting onto my math lab, but I think everybody got their quiz taken. Jordan, I will get you emailed. So, okay, if you have any questions, please reach out to me. Otherwise, we will just continue on.